Okay, after we define all the elements, now the next step is to define the sections. And now we have, as you see here, we have concrete material, concrete sections, 0.25 by 0.5 rectangular sections. So I will go to the section and shape here and select this one, and I will go to concrete. And in concrete, we have two options. The first option is to use the predefined section, and the second option is to define the section directly. And I will start with this. I will select define assign shape directly. And in this menu, I will go to concrete, and you can find here the rectangular section option. So I will select the depth of the section to 500, and the width is I will select it 250. And be careful about the unit. The unit here is millimeter, as you can see. And I will say okay. Okay, I will say okay. This is one method. The other method is to go to the section list here, okay, and start to define sections that can be used for different members. And how to do this? We go to concrete like this and start to define new section, or because look at this first. We have like list for different shapes of sections, and for sure we go to concrete because we need to define concrete section. We already have section predefined here, so I will click on this to modify it. The section that is predefined is 300 by 300, so I will modify this to 500 by 250 because I need it with this dimension. And the type of this section can be beam or concrete or bracing, so I will select beam. The material also, you can see that you have predefined materials. So this will make no difference because we will not perform the design. And design rules also, you can identify design rules for this section, and we will not change this. We just will use the typical. Okay. And I will close this, and now we just will go to this, then select concrete and select concrete one. Okay. Okay. And again, we have the type here is beam. The design list, we don't have like design list because we are not performing design. And if you select one of those, this will make no difference. The material, as I said, the typical, like the default material will work very well because we are not performing design. We just need the Young's modulus to perform the analysis of beam element. Okay, and this is how can we identify or how can we define the sections. The next step now, we will go to define the connection, the boundary conditions. And what I mean by the boundary condition are the supports here. We have support, roller support at A and B, and we have fixed support at E. So I will go to the boundary condition here, and I will click. This will give me this table, and I need to identify the node number or the node label. I need to identify the X constraint and the Y constraint. And for number A, for node number A, I need to identify X. I will leave it as this, and Y, I will make it fixed. And I will say enter. For B, it will be also fixed at Y direction. Enter for C, it is not C, it is E. Okay, so the X will be fixed, the Y will be fixed, and the rotation also will be fixed because this one is fixed end, and the fixed end, as you know, has 3 reactions. Okay. Okay, we can see here that we can observe the shape of the support, and you can control this from here. Okay, from this button. We can also control the appearance or to show or hide the node label or the joint label by using this one here. Okay, the member number also can be identified from here, and you can switch between the material, the direction here. We have the number in the list. I think this is, you have material, You have label, you have shape, you have section set, you have material set, you have local axes, you have length. This one, for example, is the length. Okay. These are the important things. So we use the label. I like most of times I just use the labels here. Okay. So we have the elements defined, the section defined, the end supports defined, and the end supports, I mean the supports for all the nodes. Okay, node A, B, and E. And we need now to define the loads. This will be in our next video.